The limit as x approaches 5 of x squared plus 2x plus 6. The limit as x approaches 3 of x squared plus 4x plus 1 all over x plus 2. We'll find out later if it's recording. Alright, to be honest with you, this first one really should have parentheses around the x squared all the way to the 6. I wonder if it didn't go through. Sorry about that. There's two types of limits that we're going to have in this class. Limits where x approaches a number, and limits where x approaches infinity. We don't do infinities today. We'll barely get through numbers today, though. If your limit is approaching a number, the first thing you do is you plug in that number. And if you get a number, you're done. So for instance, let's plug in, apparently we're going orange. I'm going to go back to blue. Let's plug in 5. So we'll have 5 squared plus 2 times 5 plus 6. So if you evaluate this, what is 5 squared plus 2 times 5 plus 6? 41. So just like we did with our very first example of that profit function, we could have just plugged that number in and then got our limit. We learn later on why it works, but for right now, we are good to go. How about our second one? We're approaching x to be 3. We'll do the same thing here. We'll have 3 squared plus 4 times 3 plus 1 all over 3 plus 2. Do we get a number? 22 fifths? Awesome. We're done. Hooray. So the first one says as the function approaches 5, the y values get closer to 41. The second one says as x, approaches 3, the function gets closer to 22 fifths. But as we saw, plugging in a number doesn't always work. And I think that's our next example. So let's try one of those. Suppose we have the limit as x approaches negative 4 of x squared minus 16 over x squared plus 2x minus 8. And the limit as x approaches 1 of the square root of x minus 1 over the square root of, over x minus 1. So for the first one there, please start off by plugging in negative 4. Please be careful with your negatives. What do we get upstairs? What do we get downstairs? 0. What is this called? The word I can't spell, indeterminate form. I'll just do that. When you have indeterminate form, and it's a rational function, meaning a fraction, there's 2 steps you want to do. Actually 3. You want to factor and cancel, and then reevaluate. So x squared minus 16, how does that factor? X plus 4, x minus 4. And x squared plus 2x minus 8. Does anyone remember what we're canceling out here? Well, as far as the graph is concerned, what are we taking out of the graph? Courtney Love will know the answer. What was the name of her band? Yeah, that's why she's still around. Hole. There's a hole in the graph. So by canceling the common factor, you're taking the hole out of the graph. So we'll do this again. We'll now do the limit as x approaches negative 4 of x minus 4 over x minus 2. So we're approaching a number. So we'll just plug that number in. What do we get? So that's 4/3. So if you have a fraction and you get indeterminate form, do not say 0. It may not be 0. Factor, cancel, reevaluate. So let's do it for this one as well. Let's plug in 1. So we'll have square root of 1 minus 1 over 1 minus 1. What do we get upstairs? What do we get downstairs? So besides a headache, we have indeterminate form. So what should we do? There you go. Factor, cancel, evaluate. I'll do the hard one for you. That one doesn't factor. But x minus 1 does. I think we need corporate sponsorship in this class. Maybe like Tylenol, Advil. Because this one hurts. It's terrible. Well, it's really a difference of squares. It's really square root of x plus 1, square root of x minus 1. Obviously, but remember the thing is that if you have 0 over 0, that means they have a common factor upstairs and down. So since the numerator had a factor of radical x minus 1, the denominator better have a factor of radical x minus 1. So if we cancel that common factor, please be careful with this one. If something cancels completely, what are you left with in the numerator? 1. Notice also that I keep writing this limit thing. You do not write the limit thing when you're actually plugging the number in. You do write the limit thing when you're doing the algebra part of it. It will not kill you to keep writing limit. So, plugging in 1. What is 1 over the square root of 1 plus 1? 1/2. So, as we did in the first two, actually all 4, plug it in. If you get a number, great. If you get indeterminate form, factor, cancel, reevaluate.